Compound interest. Please make sure your homework will be to make sure the formula makes it to your study sheet. Page 16. Compound interest is interest that is earned on both. Okay, it's interest that's earned on both principal and the accumulated interest, not just on the principal. Okay. And so most financial institutions like banks, credit cards, credit unions either pay or charge compound interest. Okay. Compounding periods refers to the amount of times the interest is calculated in a year. The more the better when you save. When you owe, not good. The more is actually worse. But when you want to earn money, the more compounding periods there are, the better for you. When you see the key word compound, and I'm going to switch colors here, say bye-bye to simple interest formulas, okay? Like, don't be grabbing your simple interest formulas if you see the word compound at all, okay? Since you're earning interest on previous interest, it creates a snowball effect, right? There's a snowball effect. Your investment will grow essentially faster, and similarly, your debt will cost you more interest as well. Therefore, the relation between time and money is exponential. So when you talk compound interest, it's going to be an exponential function. It's going to have the exact same properties that we talked about during exponential functions, right? When we covered those functions. In general, we start with an investment, right? You start with an investment called the principal and expect to earn interest. The value of that investment after a period is future value. So the value of the investment after a certain time has gone by is what we refer to the future value. Sometimes students are confused because they're like, but I already know what it is. Why is it the future value? I know it now. Like, yeah, but just think about it. That's what we're kind of aiming for. That's what we kind of want to have in the future. When interest is compounded annually or per annum, the formula, this is like the legal term. Like if you ever sign a credit card contract, this is what they're going to use on that. That's why I wanted to throw it in there. It's per year, okay? Per year if you want to. It's probably Latin, right? It's derived from Latin. The formula looks like this. I don't really want you to have this formula anywhere, okay? Don't include, okay, on study sheet. Because then you're going to mix them up and the other one works every time, okay? But when the compounding periods change, it affects both the interest rate and the exponent. So here we go. This is the one I want you to have. Absolutely, this one right here. There's the compound interest, there's compounding periods. So this whole thing here needs to be on your study sheet. You may not necessarily need every variable to be defined. You might just know what they are. But the new word here is that N is the compounding periods. That is new. Okay? That is what makes this different to the simple interest situation. And plus it's compounding and it's exponential. And compounding periods. Some students have a problem remembering what does like compounded annually mean? I mean, that one you should know. It's once a year. If it's monthly, well, that's 12 times a year. Quarterly, 4 times a year. Bi-weekly, 26 times a year. Semi-annually, 2 times a year. Semi-monthly, 24 times a year. And weekly, 52 times a year. These are the most common compounding periods you're going to encounter. So if you need to have this on your study sheet, I cannot tell you this on the test or exam. Okay, I can't remind you of that. So it's your choice of how you want to do that. So this is definitely study sheet material. Okay, I just want you to know that if you compared them side by side, if you went simple versus compound. Simple interest, if you compare time and A, which is our future value, that would always be like you start off with some sort of amount and then it just goes up like this. If you were to graph a scenario where interest is compounded and you compare time and the amount that you have, it would go like this. It would start like this and then curve up exponential, right? That's why it's an exponential growth. So this would be, under the graph, I'll say constant growth. This is exponential growth. Now, what I don't want you to think is that exponential is always better, no matter what. I will say in general, yes, if everything else is the same, but I will give you the example right here. Which is better? That's what I'm going to title this little diagram here. Which is better? Well, you have to always analyze and do some math. But let's say in this graph, we compare time and how much money you have. And I tell you that you've got two options. You've got an option where you deposit $2,000 and under simple interest growth, okay? And you go ahead and graph this, and you get this. Or option B, you've got $500 to deposit, compounded, okay, this is compounded. I'm going to use a red pen for this one, or some color. This is compounded, so we know that this is going to happen. There's a point where you have to make a choice which one is better for you in this case. So let's make a dashed line. So at the very beginning, time goes by, compound is underperforming your simple interest, correct? But there's a point where compound is going to catch up, meet where you were under the simple interest investment, and actually far exceed it. Boom, it's just going to explode even further up after that. So here, right, this is kind of like what should I call this? Meeting time. So let's say it's 50 years. I'm going to go example 50 years. Let's say it takes 50 years for you to get to that point where you meet the other investment. So you're going to decide, like, well, what should I do? Well, if you expect to use that money within 50 years, you're going to want to go linear, simple interest. If you want to use the money 50 years, like past 50 years, then you probably want to go exponential. So I will just say this. Anywhere in here, simple is better. Can you see that? Anywhere here, compound is better. What's your homework? Formulas, yes. Add this to your study sheet.